Hi everyone and welcome back. So this is your last algebra going into geometry lesson. Alrighty, so let's just get to it. Let's start by categorizing angles. So acute angles, these are all acute because they are less than 90 degrees. So those angles are all acute because they're less than 90 degrees. And I'm just going to refer to these angles as x. So let's say all these angles, we'll refer to them with the variable x. So we would say x is less than 90 degrees for the angle measure. Now if I call this angle here x, that's the obtuse angle. And obtuse angles are between 90 degrees and 180. Notice there's no equals, that would be incorrect. You're between 90 and 180 degrees. So if this angle here was 91 degrees, it's obtuse. Obviously it's not, just from looking at it, but hopefully you get the picture. Right angles, that's when it is 90 degrees. So this is a 90-degree angle right here. And then congruent angles is when all angles are equal to each other. So in this situation, if all of these angles are equal to each other, we would actually call this an equilateral triangle. And equilateral triangles, all of their angles, all three of these angles are going to be 60 degrees, which should make sense because there are three angles that are all the same. So if I have 180 degrees divided by three angles, that's how I get 60 degrees. So each one of these angles is going to be 60 degrees. That's an equilateral triangle. Okay, so we got our definitions for acute, obtuse, and right. Those are the different kinds of angles we can be talking about. So now we're going to use the diagram to classify each triangle by its angles. So whether it's acute, whether it's obtuse, so we're going to be talking about whether it's acute, obtuse, or right. Okay, so let's take a look, or if they're all congruent. So for triangle CDE, so that's right here, triangle CDE. I can immediately tell that this triangle is a right triangle because of the box right here. So we're going to say this is a right triangle based on its angle. Okay, let's take a look at triangle BCE. So let's outline that, BCE. And now immediately I can tell this angle right here is bigger. This angle right here is bigger than 90 degrees. So this is going to be an obtuse triangle based on the angle. So this angle is bigger than 90 degrees. Okay, let's take a look at triangle ABE. So triangle ABE, that's here. And all of the angles are congruent. So this would actually be an equilateral triangle. Again, that's because every single one of these angles is the same. They're all 60 degrees. Okay. And let's take a look at triangle BDE. So BDE, that's this triangle right here. And I can see here, if this right here is 90 and I have a little bit more, right? If I write this out, if this right here is 90 degrees and I've got also this amount too, well, this is definitely in total going to be greater than 90 degrees. So you're looking at an obtuse triangle. And lastly, we have triangle CFE. And all of these angles here are acute. They're all less than 90 degrees, so this would be an acute triangle. Okay. Now let's talk about categorizing by sides. So there are special names for when all three sides are the same, when two are the same, and then when none of them are the same. So I actually already said this one earlier. When all three sides are the same, we call this an equilateral triangle. So that's an equilateral triangle. When only two of them are the same, we call this isosceles. So this would be an isosceles triangle because two of the sides are the same. Opposite these sides would be congruent base angles. That's like a little fun fact. Similarly here, all of these angles are congruent in an equilateral triangle. And then when none of the sides, so all of these sides have different lengths, we call this a scalene triangle. All right, so we're going to start to categorize triangles based on the number of also tick marks we see. So just to kind of re-emphasize here, because I have 2 tick marks of the same length, but there's only 1 tick on each, that means there's 2 congruent legs. For this example here, with all 3 tick marks, that tells me all 3 lengths are equal and the same. And then lastly, because this last one had no tick marks, I actually drew them on, indicating they're all of different values. That means it's scalene. All right, so let's take a look. So for question 6, we want to categorize the triangle by its sides. So I'm going to outline JKM. So here's JKM. Okay. Now I see none of the sides are congruent, so this is going to be a scalene triangle. So it's a scalene triangle. If I take a look now at triangle, what do we want next? KLN, I see 2 tick marks here. That indicates that 2 of the sides are congruent, which means this is isosceles. Oops. Okay, so that one's isosceles. And now let's take a look at triangle JKN. So I'll outline that here in blue. JKN. And I see all of them have the same tick mark, which indicates that this is going to be equilateral. They're all congruent. So this is an equilateral triangle. Okay. Let's take a look at some of these questions below just to see how to categorize our angles and sides based on the angles and sides, how we would categorize the triangle. So give it a go. I would pause the video here and see if you get the same solutions as me. All right, guys, so check your answers here. Again, we wanted to categorize by the angles and the sides. I'll just pick a few just to explain really quick. So if you look at question 12, none of these side lengths are the same, so we know it's scalene. And all of these angles, it's very evident that you can tell that they're all smaller than 90 degrees, hence the acute. For question 14, I see that this angle here is bigger than 90 degrees, so there's my hint that it's obtuse. And 2 of the sides are equal to each other, which tells me it's isosceles. All right, so hopefully you got the same answers as me here. We are going to move on to just a little bit more vocabulary with isosceles and equilateral triangles. So just to kind of run through this here. Parts of an isosceles triangle. So in an isosceles triangle, I know it's a weird word to spell. We have 2 congruent sides are called the legs. So here would be our legs. They're congruent. The angle where the legs intersect, that's called the vertex angle. So that would be here. So angle 1 would be our vertex angle. The side opposite the vertex angle is called the base. And the base is opposite. So opposite that vertex angle. So this would be my base right here. And then opposite the congruent sides. So let's see. Opposite the congruent sides or the angles along the base. Those are our base angles. So these are my base angles. Okay? Alrighty. And then just to kind of quickly note about the equilateral triangle. All angles are 60 degrees. All sides are congruent. That's our symbol for congruent. And equilateral triangles, all of them are acute. So this is actually true for all equilateral triangles. Alrighty, guys, let's do some practice now. So we're going to apply what we've just learned about sides and angles of isosceles triangles, and hopefully we get these right. So let's do question 1 together. So if this triangle is isosceles, because I can tell from the 2 tick marks on the sides, 2 of the sides, I know that the base angles are going to be congruent. So if this angle is 68, then that means this one is 68. So the measure of angle J is 68 degrees. But now, how do I figure out angle K? It's not congruent to the rest of them. Well, if I know triangles sum to 180 degrees, I know one of the angles is 68, and the other angle is 68, I can just subtract them out. And we end up getting 44 degrees. So this triangle would be acute, and those are the 3 angles. Okay, let's take a look at question 3. I want to skip over here. Question 3. So I have two of the base angles are the same. So I know that the sides opposite those base angles are going to be congruent, hence my tick marks here. So I know this is isosceles for sure. And I know if this is 77 degrees and this is 77 degrees, let me try to clean this up, sorry. So if this is 77 degrees and this is 77 degrees, I can figure out what this angle is by subtracting them from 180. So I have 77 and then take out another 77 and we end up getting 26 degrees. So that's the measure of angle Y, 26 degrees. And now the length for YZ, that's a great question. Well, we know if this angle is congruent to this angle, this is an isosceles triangle. So this side will be congruent to this side. And if this is 12 centimeters, then so is YZ, 12 centimeters. Awesome. Okay, why don't you guys give question 4 and 6 a try. So pause the video here, give 4 and 6 a try. All right, so when we set these two equal to each other, because this triangle is isosceles, meaning these base angles here are congruent. So when I set them equal to each other and solve for x, I get x equal 13. And now just be careful that we're reading directions. It does say just to find the value for each variable. A lot of times on the regions, they'll want you to plug this back in and get what the value is. Okay, let's take a look at question 6. So pause the video here and let's see if we get the same solution. All right, and again, we set these equal to each other because we know this is an isosceles triangle. These base angles are congruent, which when I go opposite from those base angles, I know that these sides are then going to be congruent. So I set these two sides equal to each other and got x to be 3. All right, so that was practice with isosceles triangles. Now we're going to take a look at equilateral, which we've already talked about a little bit in this lesson and previous lessons. So a triangle is equilateral if and only if it's equiangular. So what that means is equal angles. All the angles have to be the same. And if all the angles are the same, then all the sides are the same. So if measure of angle A equals the measure of angle B, and that equals angle C, then all angles are 60 degrees. If side AB is equal to side BC and side AC, so if these sides are all equal to each other, then the triangle is equilateral. All right. So let's take a look at some practice problems. So we're going to find the measure of each missing angle. So if I know that this is 60 degrees and this is 60 degrees, I know for a fact this is also 60 degrees. Because if I were to do the math, 880 minus 60 minus 60, because I'm subtracting out these two angles, I will end up getting 60 degrees, which is right here. So measure of angle C we know is 60 degrees. This is an equilateral triangle. So if all of these angles are equal to each other, well then we know all of the sides are equal to each other. So if this is 9 feet, then also this is 9 feet, and this is 9 feet. So all of these would be the same. Okay, nice and simple. Equilateral triangles, everything is the same. Okay, let's take a look at this next example here on my right, this one. So we want to know what the measure of angles J, K, and L are. Well, guys, look. This side is equal to this side, which is equal to this side. If all sides are the same, all of their angles are the same. And if all the angles are the same, then all of the angles are 60 degrees. And now I didn't ask this question, but I very well could have. If JL is 24 centimeters, then what are the rest of the sides? They're all 24 centimeters because, again, this is an equilateral triangle. Okay, let's take a look at this next problem here. We have PQR as an equilateral triangle, and we're going to solve for X and Y. So we got a lot of algebra going on here. So if it's equilateral, I know this angle equals this angle, which equals this angle. And I know this side equals this side, which equals this side. And now more specifically about all these angles equaling each other, I know all these angles are 60 degrees. All of them are 60 degrees. Okay, so let's start with the sides. We're going to set these sides equal to each other. So I'm going to set these two equal to each other. I could have also set these equal to each other. It doesn't matter, as long as I'm setting a pair of sides equal to each other. So I'm going to go with setting 4y minus 59 equal to 9y plus 1. You could have also done these equal to each other or these equal to each other. It doesn't matter. They're all going to be equal to the same thing. So yeah, maybe I'll do what I have highlighted here in red. So we'll do 14y minus 59 equals 11y minus 23. Get y on the left. We always like that variable on the left. All right, just going through my algebra here. And we're going to add 59 to both sides. And we end up getting 3y is equal to 36. Divide both sides by 3, and we get y to equal 12. And let's just make sure we answered the question. So we solved for y, now we got to find x. Well, x is going to equal, let's see, we have to find the angle. Now remember what I said here. This angle here is 60 degrees, and it's also being represented by an expression with a variable. So I'm going to set these things equal, because I know this 7x minus 3 is equal to 60 degrees, because all angles in an equilateral triangle is equal to 60 degrees. So I'm just going to do a little bit of quick algebra here. And when I divide both sides by 7, I end up getting x to equal 9. So there you guys have it. Y is 12, x is 9. All right, guys, we're almost done. We're just going to do a few more problems. Okay, so we're going to be looking at solving for sides using algebra. So we're given the fact that ABC is an equilateral triangle. So I know all these sides are equal to each other. So I know 49 equals 3x plus 1. I know that 49 equals 18y minus 41 because these things are equal to each other. So I'm going to solve for x and y. I just created two equations. I'm going to draw my line down the equal sign, subtract over that 1. I have 48 equals 3x. Divide by 3. I'll get x to equal 16. And let's add over that 41. And I will end up getting 90 is equal to 18y. Divide by 18 on both sides, and I'll get y to equal 5. All right, so it was as simple as that. I solved for x, solved for y, using the fact that all sides are equal in this scenario. Why don't you guys give question 2 a try? Again, this is an equilateral triangle. Give it a go. Pause the video here. All right, so very quickly, what I did here was I solved for x. Again, all of these things are equal to each other, so it doesn't matter which set you decided to set equal. You could have set these equal to each other. You could have set these equal to each other, or you could have set these equal to each other, which is what I did for my problem. Now, the last part says find the measure of each side. Now, you should only need to plug into one of these because all the sides are going to be the same because it's an equilateral triangle. So I'm just going to plug in for whichever one I feel like plugging in for. Maybe I'll plug in here. That looks like easy math. I have 10 times 8 minus 6. 10 times 8 is 80. 80 minus 6 is 74. So that tells me each side length, so ST, is going to equal RT, which is going to equal SR, and they all equal 74 for the lengths. Okay, well, why don't you guys give question 4 a try? Let's take a look at question 4. Talking about an isosceles triangle now, so note the difference. Isosceles triangle, so if I know that DE is congruent to EF, so that means DE is congruent to EF, that means their base angles are also congruent. All right, so why don't you guys solve for x and then find the measure of each side. Pause the video here. All right, guys, so there you have it. So I was able to figure out that x is equal to 10 because I set these two sides equal to each other, what I have highlighted here in green. So I set those two sides equal to each other because this is an isosceles triangle. after I solved for x, I already knew that what I have circled here in blue and red, so blue and red, those are equal to each other because, again, it's an isosceles triangle. So once I know one of the sides, I know the other side. So if one side has a length of 67 units, then the other side has also a length of 67. I can't assume that this down here is also 67 because I was told it's isosceles. This would be 67 if I was told this was equilateral. Okay, but that's not the case here. Not the case. So we have to go off of what we know. And that is that we only have what x is. So if I have x, well, I'm just going to plug in for x. We have x is equal to 10, so I'm just going to plug in 10 here. And 10 plus 21 is 31. So we would write that the measure of each side, so DE, is going to equal 67. EF is going to equal 67. And DF is going to equal 31. All right, guys, one more problem. I want us to take a look at question 5, and we are done. So let's take a look at question 5. And we are finished with the year. We have completed algebra, and this right now is transitioning you into geometry. So you're going to be ahead of the game. All right, let's take a look at this last question together. We have triangle WXY is isosceles with sides WX and XY congruent. So let's outline that here. This is congruent to this, telling me it's isosceles. I know the base angles are congruent. We want to find the measure of angle X and the measure of each side. So we need to solve for X. We need to find the length of XY, YW, and WX. We want to find all those lengths. So first thing I'm going to do is set these two lengths equal to each other because they're congruent. So let's write it out. I have 6x minus 77 equals 3x plus 4. And I'm just going to do some algebra. All right, so again, just going through that algebra, I got x to equal 27. And now we want to just go back and plug in because we want to find the measure of each side. So if x is 27, I'm going to plug that in here. I'm going to plug in x being 27 here. And I'm going to plug in x being 27 here. So maybe pause the video here, guys, and just go through the algebra. All right, guys, and there you have it. I just plugged in using algebra for x equaling 27 into every single one of these expressions. And you should end up getting that these two sides are equal in that length of 85. If they're not equal, you did something wrong because this is an isosceles triangle, so these sides have to be equal. And then lastly, plugging in for WY for x equaling 27, you get 104. All right, guys, I hope you found this video helpful. Best of luck to you all next year in geometry. I'm going to miss you all very much. Have a great day.